Lab Guy here. We're going to start today at the point where we are installing the bypass capacitors for the power lines of the power op-amps. I'm currently installing a 10 microfarad 25 volt 1206 size surface mount capacitor by soldering it directly to the ground feed through that I put in the last video. I'll continue doing this until all foreground positions have two capacitors each, a 10 microfarad capacitor and a 0.1 microfarad capacitor. At that point, we'll run wires from the power pins of the IC to the appropriate power line. The four 10 microfarad capacitors are now installed, and I'll begin on the 0.1 microfarad bypass capacitors.
Okay. No shit.
It's time to install the first power line. The route of this power line for plus 15 volts will be starting at the IC pin 1, going to pin 2, going to the 0.1 microfarad bypass capacitor, then to the 10 microfarad bypass capacitor, and then to one of the 3300 microfarad electrolytic capacitors on the plus 15 volt line. I do all this with one piece of wire.
It's a good plan. That's it. There you go.
The first op-amp power line is complete. And here we see the finished product with all four power lines in place. The blue wires are minus 15 volts and the orange wires are plus 15 volts. At this point, I'm wiring the two spare op-amps for shutdown. Here's some initial wiring of the input buffer stage. The input level controls are wired. The input jacks are installed. And here's a little more progress. Now the offset controls are wired to plus and minus 5 volts.
Today is Friday, and I've been working on this board since 8:30 this morning, and it is now 6 p.m. or thereabouts. And I've been working on it all day. It contains two high power op amps, 60 watts each. There is a quad high speed video op amp located down here, of which I use two of the op amps in the package. The other two are disabled. There are two voltage regulators with heat sinks for plus and minus 5 volts for this op amp. These guys run on plus and minus 15 volts, which will come in through the terminal barrier on the back. These capacitor banks provide surge current for fast changes that have to drive the output. I hope they're big enough for what I need to do. This strip here that goes across here is ground. It's solder braid that is wrapped around and tied to the ground plane on top of the board at both ends. And the solder spots you see are a combination of either the bottom of the capacitor that it services or a wire that I place periodically to tie to ground on top of the board. This copper rail is solid ground. This bank of capacitors, there's the two banks of capacitors. It's two banks of 3. This set of 3 is for the negative power supply. This bank of 3 is for the positive power supply. And they are tied together by this twisted bus wire. This rail is the plus rail. Over here is the negative rail. The capacitors are 3,300 microfarads each for a total of 9,900 microfarads on each power line. In addition to that, where the power comes up, a power wire, it's received at a 10 microfarad 1206 size 25 volt capacitor, a 0.1 microfarad 25 volt surface mount capacitor, then a heavy piece of bus wire over to the two power pins into the power op amp. The same holds true for the positive side, 10 microfarads, 0.1 microfarads, and into the chip. Blue wires are minus 15 volts. Orange wires are plus 15 volts. Red wires are plus 5 volts. The green wires are minus 5 volts. This below this line, this op amp operates on plus and minus 5 volts, and up here these big boys run on plus and minus 15 volts. The voltage regulators drop the 15 volts to 5 volts for this guy. The setup resistors for the op amps are 0603 size surface mount parts, which I've soldered between the pins here, where you can't even see them. But all of my passive resistors are literally invisible with this construction technique. I built this ad hoc. I just picked a piece of vector board out of my junk box that looked big enough and started with the op amp and the two with the quad op amp and the two big power op amps this morning. And this is where I'm at, where I'm going to stop for today. I am in need of a pair of 1 ohm 5 to 10 watt resistors. Those will be for load sensing. I can't complete this system until I have those. But this is where we're at now. It will operate by bringing in plus or minus 15 volts at the top. The two deflection coils will be attached to their pins on the top. The drive signals will come in these two connectors down here, which each amplifier, you can think of one as X and one as Y. The drive voltage is 0 to 5 volts. The first inside pots, these are the gain pots, and the two outside pots are the offset pots, the DC offsets, or centering controls, if you will. And that is the functionality of this board. The two op amps I'm using here provide a gain of 2. The pot acts as an attenuator ahead of the amplifier, which is always at a gain of 2. I believe these may be operating at a gain of 1 when I use a 1 ohm resistor for the sense resistor. It makes it nice. 1 volt in is 1 amp out. 2 volts in, 2 amps out. In theory, these power op amps can reach a bandwidth of 350 kilohertz. I don't know if this board can make it for several reasons. One, insufficient capacitance. And my wire gauges here are ridiculously small. This is 1 or 2 amp wiring. The op amps are capable of plus and minus 5 amps of drive at frequency, I presume. And that's a whole different construction methodology. And in fact, I would lay out a laid out circuit board, CAD designed with 1 ounce copper, so that I can get enough current to the op amps. Otherwise, it's like putting series resistors with them. The power lines themselves will limit the current. So that's where it's at today. Not bad. I'm very happy with the result. I hope it works. But we can always debug it. If it doesn't work, we'll make it work.